volt, 100 amp hour. We're gonna test this and see how accurate this is. Plug this in. It's a little more than I expected. 100 amp hour battery. Run this fridge. Let's just do a quick battery capacity test. Battery outside comes up and over and plugs into this 9000 BTU mini split heat pump. Battery, in this case, run a microwave, a full-size gas furnace, a load of wash. Let's see if it will run an electric hot plate. Smart battery, run a household vacuum cleaner. Is it able to run a gaming desktop? Let's just jump into the app super fast. Inside the battery here. Here's one of my favorite tricks to do with a 12-volt battery. We all depend on internet, right? Here's a router modem combination. If you look, not all of them, but quite a few of them actually run on 12 volts DC. This particular one, if you look right by the power input, it says 12 volt DC, 2 amps. And this power adapter here, don't know if we can get that to focus or not, but right down here it says output 12 volts, 2 amps. That means that this could run directly off of a 12 volt battery. And all this does is takes AC power from the wall and converts it to 12 volts DC. So we can verify that by plugging this in. Get the slots lined up. There we go. This is also a very common plug for 12 volt items, a 5521 barrel plug. But if we take our multimeter here, we can verify voltage and polarity. So we're going to just stick the red, I'm trying to do this one-handed, a little challenging. Stick the red probe, positive probe, into the middle there. And then we'll go ahead and touch the negative probe. And we can see we're reading 12.19 volts. Now if we were to switch the polarity, we would have a negative, which I don't know if you can see, but it says negative 12.18 volts. So we know that the center point is the positive in this plug. So what I've done here is I've just wired this up with some cable. Again, it's only 2 watts, so we don't need big honking cable for this. Just some skinny cable, and then I got just this 5521 pigtail in a pack, a big pack on Amazon, really cheap. I'll leave a link for that down below. But I've just crimped those extension leads on, wrapped them around the terminals on the battery. The red in this case is positive, obviously, and then I didn't have any dark wire, so I just colored the yellow wire black there a little bit, just to mark that as negative. And if we were to do the same test here, the red probe in the center hole there, and there we can see the polarity is correct, 13.3 volts. Now DC things are generally fairly forgiving as far as voltage goes, so long as you're not insanely over what it is, we should be fine. We're only 1 volt over, so this should fire right up. So before I plug the battery in, here's the power cable. It's plugged in here. Let's plug this in, and we'll see that we have the power light, and it will proceed to go through its boot up process. We won't go through the whole boot up process here. I'm just showing you that it's powering on with the normal one. You can see a little hard to see with the glare, but we've got a flashing green light and it's booting up. So let's do the same thing here. We'll plug this in. And you can see we've got the light on. We're all booted up here. We got the green light up here. Got the Wi-Fi light on. So now obviously I'm just kind of bench testing this here. It's easier to see this here instead of in the closet where the router normally goes. If we come over here to the little screen, it doesn't even register. It's just saying 0 current and standby. It's not even registering that there's discharge just because of how small it is, right? This clamp meter, without being clamped onto anything, you know, is showing 0.5, 0.4, 0.3. So if we clamp it on here, it is within the margin of error. It's showing, you know, things that, you know, it can't even detect much of a current draw at all on the wires. So let's just take a worst case scenario. Let's say it uses a full 2 amps, 12 volts. So that would be, what, 24 watts? And so assuming this had a full charge, it would last powering this router at max power for like 53 hours and some change there. It's an extremely efficient way to power a device such as this because it's going straight from DC to DC. There's no conversion losses or anything. You know, if you try to power this with like a power station and you're running the inverter and then you're running this, you know, power brick here that we've got plugged in. So then you're losing power as you're converting from the power station's battery to AC power, right? And then you're losing power converting AC power back to DC power to just get 12 volts, 24 watts, you know? So anyway, this is a fantastic, inexpensive way to power your 12 volt DC devices like this internet router for a very extended period of time and not have any conversion losses. The other nice thing is with this being lithium iron phosphate, it has a very flat voltage curve. And so you're going to be able to draw pretty much the entire capacity of this battery with this load. And you don't have to worry about the voltage sagging below a point that this can comfortably use it. So anyway, great use case, super inexpensive and easy, and is the answer to a lot of people's problems during a grid down power outage situation. Here's another fun thing you can do with one of these batteries. You can expand the capacity of one of your existing power stations on the cheap. Now, it shouldn't charge it ridiculously fast, but if you're just charging, you know, electronics, laptops, running a TV, even a fridge, you know, as long as you're sub 100 watts, or even if it surges above that for a little while, the battery in here can take care of it. And then, you know, once the heavier load shuts off, then it can recharge. But it will go slightly slow, but the trick is to just adapt it to go into your power station's DC input, okay? So in this case, the Anker Solix C1000 has an XT60 connection. So in theory, we should get 100, 120-ish watts of input power from the battery. I just built this super simply. Just had some leftover 12 gauge wire here. In this case, it's solid, it's not stranded, just to maximize my current carrying capability. And I just wrapped it around the terminals here, and then you can get these XT60 adapters again on Amazon, super cheap, and a whole pack of them. I'll leave a link for them down in the description. Okay, just plug it in there. And we should see this power station start to charge. Ramping up here. 61 watts. 85, 103, 119, 129. Wow. It's a little more than I expected, but I guess with the battery voltage being probably 13 something at the moment, let's see, 13.3 volts. So that makes sense. So anyway, 10 amps, 13.3 volts, pretty darn close to 130 watts. So that works great. So again, this is semi-slow, but it's a great way to just dump a little extra power, especially at night or whatever, when you might not have solar, into your power station and just prolong the runtime. This is recognizing the current, 9.7 amps at the moment, 9.8, vacillating back and forth, just a little bit discharge. So that's pretty awesome. And again, if you compare the cost of, you know, an adapter, you can use some spare leftover wire if you've got it, and one of these batteries, which actually has more capacity than the internal battery here, or an additional battery that you could add to this particular power station, and it's a fraction of the cost. So it would work really well, again, if you have just a lower draw appliances but prolonged use, like a fridge, for example. Okay, now this is the Delta 2 Max, the 12 volt battery, currently connected into one of its inputs. Now the awesome thing about this unit, one of my favorite features, is that it has two DC inputs. Can both receive lower voltages, like 12 volts. So I have just one connected at the moment. We're just over 100 watts, okay? But check this out. Because this battery can discharge up to 100 amps, you know, we're only gonna pull like 20 amps max with both of these. So we're gonna connect a second input, and it's just going to the same terminals on the battery here. But we should see this double in wattage. Yeah, look at that. Now we're pulling over 200 watts input. So that adds a lot of functionality to this Delta 2 Max. Okay, so just a quick demo of something on the app for this battery that's pretty cool. So you can see that we're discharging it to about 15.7, 15.8 amps. We're dumping it power into this EcoFlow Delta 2 Max, charging at about 210 watts. So something pretty cool in this app is you can actually turn off the battery from discharging. So I just shut it down, and you can see it's off, no more discharge. And if we come here, we have no more current going into the power station. So that's kind of cool that you can remote control the output of the raw battery from your phone. So same thing with the charge. If you want to stop it from charging, you can flip that switch and it will stop charging. So we just turned that back on, and if we come over here, we can see that the Delta 2 Max is ramping up back to where it was originally. Okay, let's just do a quick battery capacity test on this 12 volt 100 amp hour GoKWH battery. We just finished charging it up to 100%, and we've got the Victron Smart Shunt. It's over here. Now before anyone complains about this red wire here, on the negative side, I recognize that this was just the only one I had with the correct size terminals. So anyway, but this is the negative side, and this is the positive side over here. We've got the Victron Smart Shunt here, and if we look here, we can see that it's agreeing with 100% state of charge. I've reset everything. We're going to see if we can draw the full 100 amp hours on this test. And we're going to try to be as close to a 0.2C rate of discharge as possible. So it's coming over here to the Renogy 3000 watt charger and inverter. And yes, one more thing, this is not the correct setup. Right now I'm just doing a bench test on this battery, so I've temporarily disconnected this from its permanent setup and just temporarily wired in some wires. We're going to be dumping the battery charge into this power station. Without further ado, let's flip this on. So it looks like we're about 18 amps, so I'm gonna see if I can turn this up just a touch. Okay, I can't get it quite dialed in. We're at 26 amps right now. 26.3, 26.5, right in there. The inverter just shut off. I think it just shut off on low voltage cutoff because the battery still seems to be on. 10.9 volts though, saying 0%. And the shunt is agreeing. Unfortunately, we got 98.8 amp hours, so nearly 1 amp hour away from pulling full capacity on this. So really close, probably within the margin of error. Inside the battery here, couple things off the bat. The lugs are extremely tight here. I cannot budge them at all with my hand, so that's great. And then notice the packing in here, and I'm not going to tear it out any further because this is major. But this foam is extremely hard. It's got all this glue everywhere holding it in. We've got another piece down in here. We've got some here on the top, more here on the side, more here in the back. The cells and the pack is not going anywhere. And that's a big deal. I don't know if you've seen the original ones of these, but there was a lot of just kind of haphazard packing. It was quite loose and flimsy. Not so anymore. This is extremely robust, extremely nice. So I'm not going to tear more into it. This is as far as I'm personally going. One thing to take note of is this white seal right here. When this lid closes, that cinches down there and provides a nice seal. I would have no issue at all using this, and relying on this, which I'm going to. That's why I'm gonna not tear this apart further, because I want to still be able to use this for some stuff here. It did everything and passed everything with flying colors. The only thing I didn't quite get to spec was a full 100 amp hours. I got to 99, but that's possibly a user error. And definitely within the margin of error. So some things that are really awesome is the connectivity and smart aspects. This little screen right here is extremely accurate. I compared it throughout the tests, as you saw, with Victron's Smart Shunt, and this was very close. So whatever they've got going on internally is extremely accurate now. This is super handy. I found myself referring to this all the time throughout the video and the tests that I ran. So extremely handy. And then the smart app for it as well has been extremely handy. Best news is you get all of this in a fantastic package for a really awesome price. This retails for $329. I have a link for it down in the description below, so be sure and check that out. But it gets even better. I've got an exclusive coupon code down there for you guys, and that's going to bring the price down sub $300 all the way down to $269. So I think that's a steal of a deal for what you're getting. And just be sure you get this model with the smart screen. It just has the power button. Last time I went there, it looked like you could still get the original one of these that did not have the great packing and the nice screen and everything, the app control. I think it's well worth it, the few extra dollars to get this. And again, at 269, you really can't lose. Hopefully you guys liked this video. If you did, be sure to give it a thumbs up and subscribe, because we've got a lot of other cool things in the pipeline here for you. We'll catch you next time.